I'm not going to be able, I don't think, to get through as much of the logarithms as I wanted to between now and Friday. So my plan is I'm going to teach today, today's Wednesday, teach tomorrow, that's Thursday, and then maybe a little bit on Friday. I think by Friday it will make sense to you, and then that will be it for the logarithm. So let's then talk about what I'm going to start you by looking at what we mean by an inverse. And this is a really important idea mathematically. And we know that when we have let's do that a little bit.
Do you want us to write this all down?
I think it would be good for you to have the definition, and that way you can refer to it. Renee, there's no way you can just prop it down on the desk? No?
It wouldn't.
You're going to get a stiff hand if she doesn't get it tried on. You're okay?
Yeah.
You're the best, thanks. Okay, so an inverse, when we're talking about an inverse, is what we're going with. We know that a relation, there's a definition, a relation is a set of ordered pairs. So if I had ordered pairs, okay, if I had a -2, 1, 3, 4, 5, 0, and I think that's a 7, -7. And if I asked you what the domain was, the domain are what? All my x values, and in this case it would be a -2, a 3, a 5, and a 7. And my range is the 1, the 4, the 0, and the -7. Okay, so those are my y values. And an inverse is when I switch them around. And it's really important that you understand the difference between an inverse and a reciprocal. And mathematically, sometimes people get those mixed up. So I really want to make sure that you understand the difference between an inverse, and we're interchanging the domain and the range of a relation. Okay, so I'm going to switch them around, and I'm going to create a new relation. Does that make sense? So what was before all my x values, all I did was flip things around. So now I have 1, -2, 4, 3. So instead of having 3, 4, I'm going to have 4, 3. I'm going to have 0, 5, and a -7 and 7. Okay, so that's important to know what an inverse is. Okay, so far so good? The domain and the range, because the domain are my x values, and the range are my y values, and I'm switching them.
Well, I get that, but what's the relation?
Of a relation, you create a new relation. Okay, so we're creating a new relation. Okay? All right. And so, what I did was, I'm going to just show you before I did this, I had y equals 2 to the x, okay? And if I did the inverse, what am I going to have?
2 to the y.
X equals 2 to the y. Okay, so what did I do? I switched my x and my y's around. And I know that when x is 0, my y is going to be what? 1. When my x is 1, I have 2, and I just went through and I had a couple of different values, and then I did the inverse and I flipped it. So in this case, when my y is 0, my x is going to be 1, and we can see we flipped it. And when my y is 1, excuse me, my x is 2, etc. So let's just look at what that does graphically. And can you guess which one is which?
Y equals 2 to the x.
Okay, let's number them, 1 and 2. So we had y equals 2 to the x, and we had y is equal to the y, no luck? Okay, thank you.
But the top one's 2 to the y.
Top one is 2, the top one's 2 to x.
the x?
Perfect.
Okay, the top one is y equals 2 to the x, okay? And is it going to be an asymptote?
Sort of.
Maybe.
But it goes
No.
this way?
No.
Why does that have that?
Is the graph going to touch 0 on the x-axis?
No.
No.
Okay, so is there an asymptote?
Yeah.
Is it horizontal or vertical?
It's kind of an angle.
An asymptote, is it ever going to hit 0? Oops, sorry, I don't know if I can draw a straight line. It is going to be what kind of an asymptote? We have a horizontal asymptote there. We know that our function will not touch 0. Yes?
I thought asymptote was the line that went through both of them, not touching either of the lines.
Yeah.
That was when we had rational equations, and we had, or a rational expression, and we had an x in the denominator, but they can be horizontal.
So
An
then-
asymptote is just saying something can't happen
So
there.
does that asymptote continue on?
Yeah, well, it doesn't need to, because you can see that the graph, you know that the asymptote is at x equals 0. Okay, that's where it exists. Is there another asymptote on the other equation?
Yes.
Yeah.
And that's going to be at what?
Horizontal.
Well, it's going to, no, it's going to be vertical. We can see it's not going to touch what? When y equals, or I'm sorry, this one is going to be when,
That one's x equals zero.
this one is x equals 0, and this one is y equals 0. That's right.
So that corner is the x. So.
Okay. The point that I'm trying to make is that when I have one equation and I take the inverse, it does what? It flips it, okay? And we changed our x and our y values, and we graphed it. And for all, and why do you think that might be a handy thing to have? Why do you think that this might be a good thing to be able to do?
Because it's math.
You got it?
It's just-
Okay, so what I'd like you to do is, why don't you graph y equals 10x. And we're gonna graph y equals 10x. Let me see. We might have to change our window. And, sorry, I'm gonna have to change my window. 6,
10x, you said?
yeah. Did I do this right? 10 to the x, sorry, I just graphed y equals 10x, so it's y equals 10 raised
No way.
to the x, right? So you should have a graph that sort of looks like this. I'm going to change my window a little bit. So am I interested in these negative values?
No.
No, so I'm gonna just get rid of these, y minimum, I'm gonna put it as -1. And I'm gonna change my x max, I'm gonna make it 100. Okay, and so I'll make my scale maybe 10. Okay, everybody good with that? What happened to my graph?
You have to go the other way. It has to be like x equals 5.
Wait a minute. I had an x minimum of 0, x max, sorry, I didn't want my x max to be that. I wanted this to be, let's just make this 3. And I meant to make my x max 100.
The y
Wait.
Okay.
max. Y max.
I'll show you what I did, I'm sorry. I wanted my x min to be negative 10, it doesn't have to, I could make it a negative 3. It doesn't, that's not what I'm looking for. My x max is 5, my x scale could be actually 1 minimum. Alright, so we'll make this 20. Okay, that looks better. Okay, so how would you go about solving 47 is equal to 10 to the x?
Okay.
Well, now
What do
think
I do?
about this.
47?
Think about this.
40.
What is 10 to the first?